Alright guys, so this is just a little bit more review regarding regression. So this problem here's first thing is it gives me some data. Okay, so square inches of the TV versus price, so area of the TV versus price. Use your calculator to find the regression line. So I went ahead and just put it in all my data, the same data I see here. And I'm going to, you won't have to do this for a test guys, but I'm going to go ahead and make the equation here. So the X list is A and the Y list is B. Oops, I should just put B here. Okay. So my regression line ends up being y hat is equal to a plus bx, which is equal to 105.737 plus 0.769 x, where y hat is the predicted sales price of the TV, and x is the area of the TV, of the screen I should say. Okay, so I'll explain what is meant by least squares in the least squares regression line. So least squares, guys, remember this is all talking about the response variable. So it is the regression line that minimizes the sum of the squared deviations between the observed prices. So all of these are like actual observed prices, and the prices predicted. Okay. So the manufacturer produces television screens of 943 inches squared. What would be reasonable to use the equation to predict the price of the television? Okay, so excuse me. So 943 would be somewhere out here if we look at this. So this is outside the range of the areas that we've already have values for. So we don't know if this would be a good fit for this type of screen area, just because it's outside of the range that we have already, I guess, that we've found data points for. So when I have something like that, something that would be out here, this is what we call extrapolation. Okay, so would it be reasonable? Well, that point, the point would be on the range of data points collected. So this would be what we call extrapolation. Okay, so calculate the residual for the television screen of 437 square inches. So let's look at that. It's this one right here. And what does this number suggest about the cost of the television? So The 437 is this one. So this was the actual price. So remember, residual is equal to y minus y hat. So actual minus predicted. So the actual price here was 375, and the predicted we can find over here. So the equation was 105.737 437. So go ahead and find that number. So the predicted value was 441.79. So the residual here would be negative 66.79. So pretty big difference here. So here we actually overestimated. We got a pretty good deal then. So we overestimated the price. Okay. So we got a good buy here. Because the estimate was an over prediction of what we actually paid. So okay, so moving on here to the second problem, and this one was given to you. So again, this right here is going to be the B value. This will be the A value. So what is the equation for the least squared line? So it's y hat is equal to negative 3.822 plus 5.215x. Okay. Is this line an appropriate model for this data? Oh, well, I guess we should be more specific over here. We're not done. X is going to equal amount of minutes. Oh. Sorry, I guess we need to read the over here. The relationship between number of minutes on the stair climber and the number of floors it tells her to climb. So X will be the number of minutes on the stair climber, and Y hat will be the predicted number of floors climbed. Okay, so is this a line appropriate for the model? So I mean, looking at this, everything, there's no pattern that I see, so I would say yes, this is a good fit. So since there is no pattern present in the residual pot, excuse me, the linear model is a good fit. Okay, so last thing, interpret the S. So this one right here, in the context of this problem. So S, remember, has to do with the predicted values. This is just saying that on average, The predicted values will be about 2.35 floors from the actual values. Okay, and again, this is just the difference from the residuals, so the average of the residuals here. So on average 2.35, so everything looks about to be around the 2 mark, or a little bit greater in the residual. So average of those is 2.35, so that's what that S value is telling me. So study, guys. There are a couple other things you need to look at. So how do I find outliers? What that would mean. Another one would be like the confounded variables, and the and other things. So just look at your notes on those and study. And if you have questions, you guys can contact me through the classroom.